Tell me. I think FL square by A, na? This is only half into FL square by A. Correct or not? Wait, I will solve. Instead of rho, MGL by 2A. Correct? Y, AY. Yes, Young's modulus will come. And otherwise, we can get in terms of rho is how much? Rho G L square by Y. This is the formula of elongation due to the own weight we have got. And after that, we have done some problems. And yesterday I said that we have to discuss about the torque and all, torque of the torsional rigidity. So the torsional rigidity, that derivation is not necessary, that is based on the partial differentiation it will be there, that is not necessary. First of all, I will tell you how to do that. Now, here what is the formula we got? Torsional rigidity C is equals to d tau divided by dt. From this, to get the C value, you have to do the partial differentiation of torque with respect to the theta. Okay, that is not necessary. So we have solved already yesterday itself. C in terms of neta, what is the formula we got? Tau is equals to what is the formula? Force into perpendicular distance. Force into perpendicular distance is what? Radius of the disc, radius of the circular area. So that force into perpendicular distance R, that divided by theta, nothing but what is the formula? Phi L by R, right? What is the phi here? Shear angle, and then length of the wire, and then R is the radius of the bottom surface of the wire. Then we will get it as F R square by phi into L. So F R square, F divided by F into R square by, what is the phi? Nothing but neta is equals to what is the formula? F by A divided by phi. Then phi is equals to F by A into neta. So that F by A into neta. F gets cancelled. What is the answer you will get here? A neta R square. A is how much? Where is L? Yes, L is there here. Divided by L. Then what is the formula? You will get nothing but pi R power 4 into neta divided by L. This is what the torsional rigidity. And also for the energy and all, only half of the energy will be stored. The remaining half will be wasted. Here in this also we will get only half, that is half into pi R power 4 neta by L. Okay, this is not there for the NEET, by the way. So that C is equals to, you just remember this formula, that's enough. C is equals to d tau by d theta. This is the torsional rigidity. And moreover, in that, based on the torsional pendulum or torsional rigidity, what is the main formula? Nothing but the relation between the angle of twist and then angle of shear only will come. What is the relation between angle of twist and then angle of shear? Pi is equals to what is the formula? Theta is equals to phi L by R. This is the relation between them. That relation is important. And one more thing is, we have discussed about the Poisson's ratio and then Young's modulus relations, Poisson's ratio and then bulk modulus and then shear modulus and all. So that Poisson's ratio relation, in that first of all, we have discussed about the bulk modulus relation. What is the bulk modulus? What will you get? Y divided by how much? Y by 3. Y by 3 into 1 minus 2 sigma. Sigma is the Poisson's ratio here. One more formula we have discussed as rigidity modulus neta is equals to, instead of y by 3 what will you get? Y by 2. Instead of 1 minus 2 sigma what will you get? 1 plus sigma. So that 1 plus sigma. That is the neta value we got. And after that, we have solved both of this and then we cancel the y value. So that we got the relation between B and then neta and then sigma. What is that? Sigma is equals to, what is the formula we got? 3b minus 2 neta by 2b to neta plus 6b. Correct? This is the formula we got. Sigma is equals to. And also one more important relation I said, what is that? 9 by y is equals to 1 by b plus 3 by neta. No, you just change it. 1 by b plus 3 by neta. I have said in reverse on that day. Just change it. 9 by y is equals to 1 by b plus 3 by neta. Relation between sigma, y, neta and then b. Clear? That is about the relations. And then this one is a torsional rigidity, that is C is equals to d tau by d theta. Listen here again. Torsional rigidity. I think you have written the definition yesterday. torsional rigidity C is equals to d tau by d theta. The torque produced for the angular twist, the unit twist is known as the torsional rigidity. C is equals to d tau by d theta. Now here tau nothing but torque. Torque is nothing but what? Force into perpendicular distance. Now you are applying the force here in this direction, and then in this direction you are providing the force, so that force is perpendicular to which one? Nothing but radius of the circular area. So that force and then perpendicular distance is how much? Radius. Okay, so that force into perpendicular distance, that divided by angular twist formula is what? Phi L divided by R we got. From that F R square divided by phi L we got F R square divided by, what is the phi formula? Nothing but neta is equals to, what is the formula? F by A divided by phi. Then phi is equals to F by A neta. That is what I have substituted here. Phi is nothing but F by A neta. From that area is equals to how much again? Pi R square. So that pi R square neta into R square, how much it will be? Pi R power 4 neta, that whole divided by L. For the energy stored also we will get half of the energy only. The here also we will get the rigidity as half only. So that C is equals to how much? Half into pi R power 4 by neta into L. Copy that. Actual R you will get half also, but there is more differentiation and then integration derivations are there. అది వెనక్కి పెట్టమండి వీడియో అంతే ముందుకు ఉంది కరెక్ట్గా ఉందా అంత దగ్గరకు వద్దు వెనక్కి సెట్ చేయి డైలీ ఇక్కడేనా ఉండేది కాదు కదా చూడు కరెక్ట్గానే ఉందా have you changed this one? 1 by b plus 3 by neta. Finished? Next one is thermal stress. Thermal stress. See here, I have taken a rod of length L in between two rigid supports. So what I am doing? Nothing but I am raising the temperature of this one. Whenever I raise the temperature, at that time the temperature I am taking here, let me take initially T1 temperature is there. Now I am raising to T2 temperature. Whenever I raise the temperature, then what happens? It will try to get elongated. But what happening? Nothing but I am just holding it in between two supports. Then what happens? In that stress will get developed. Don't think much, it will bend and all, it will bend obviously, but I am talking about the normal little bit temperature only. So whenever we are heating little bit also, at that time what happens? It will try to get elongated, but elongation is not happening because these two are fixed supports. So that what happens? Nothing but in that stress will get developed. That is trying to expand in which direction? Obviously in this direction only. Trying to expand in this direction and then in this direction, both the directions. I am heating middle, exactly in middle, so that the temperature, the heat is traveling from here to here, here to here. Why? Because obviously it will flow from higher temperature to lower temperature only. Now this is trying to expand and then try to expand in this direction, this end is trying to expand in this direction. So it is trying to expand but it is not able to do that, so that what happening? Nothing but in that stress is developing. That stress is developing due to the force applied by the wall. Why? Because this marker is wanted to go in this direction. I am stopping it. How I am stopping it? Nothing but I am applying the equal force in the opposite direction. With whatever the force it is trying to go in this direction, with the same force will be applied by the wall obviously. So only that is in equilibrium. Otherwise it will fall. If it is not equal, nothing but it will fall obviously. So that this wall also applying a force F on this, both are same only. F and then F, both are in the same opposite direction. Now you have to find out this F value. How to get that F value? First of all, you have to find out, obviously the Young's modulus of this material is Y here. So what is the Young's modulus formula for us? Y is equals to FL divided by A into delta L I can take. Now I want to find out the delta L first of all. I want to find out the force means you have to get the delta L here. So get the F value. First of all, F is equals to what I can write? YA into delta L by L. Clear? So this delta L by L you have to find out means in the thermal properties of matter, in the linear expansion we will get one formula that L is equals to L naught into 1 plus alpha into delta T. You remember this formula? L is equals to L naught into 1 plus alpha into delta T we will get. So this one we will discuss in detail in the heat chapter. So L is equals to L naught into 1 plus alpha into delta T. From this, L is equals to L naught plus L naught alpha delta T. L naught is what? Initial length. This is the final length after heating the object. So that here now what I can write? L minus L naught is equals to L naught alpha delta T. L minus L naught nothing but can I take it as delta L? Delta L by L naught is equals to what we can write simply? Alpha delta T. What is alpha here? Coefficient of thermal expansion, coefficient of linear expansion. Coefficient of aerial expansion will be what? Beta. Coefficient of volumetric expansion is gamma will get. In that gamma only again we will get two types. One is the apparent expansion, another is the real expansion. That will be there in terms of water whenever we are taking in the glass, and then whenever you are heating both the objects. For example, you are taking the water in a vessel. You are heating the vessel nothing but at that time what happens? Vessel also will expand and also water also gets expands. So that is a gamma apparent is equals to the difference between the vessel expansion and then water expansion we will take. That is the apparent expansion. That we will get in the volumetric expansion in the heat chapter. Okay. So that is about the volumetric expansion. By the way, we need only linear expansion here. L is equals to L naught into 1 plus alpha into delta T. From that, delta L by L naught is equals to what I can write? Alpha into delta T. What is alpha here? Coefficient of linear expansion. Coefficient of linear expansion. Now here F is equals to Y into area. Delta L by L is how much? Alpha into delta T. That's it. F is equals to YA alpha delta T. This is the formula of the force. I want to find out the thermal stress. What you have to find out? F by A you have to do. Thermal stress is equals to, this is the thermal stress. Force applied by the wall we have to find out. Force applied by the wall is equals to force applied by the rod also. So that thermal stress F by A is equals to what I can write simply? Y alpha delta T. Now tell me what is the thermal energy? What is the thermal energy? Energy formula is what? U is equals to half into, don't go for the other energies and all other energies I am not asking me. In this only potential energy I am asking. Half into stress square by Y only. So that only the thermal energy U is equals to UT is equals to half into stress square. What is the stress here? Y alpha delta T. So first of all I will write the formula. Stress square by Y into volume, right? Compulsory you have to take the volume. If you don't take the volume, then what you are finding? Energy density you are finding. So here UT is equals to half into stress square. What is the stress square here? Y square alpha square delta T square. Instead of delta T I will take it as theta. Okay, now you will get confused again. Why? Because tension also will be there in that. So Y square alpha square delta T square divided by Y into the volume. Directly we will take the volume, it will not get cancelled however. Y got cancelled. Then thermal energy UT is equals to what is remaining for us? Half into Y into alpha square into delta theta square into volume V. This is the thermal energy. Otherwise thermal energy density nothing but just half into Y alpha square delta theta square. Clear? See here we are fixing a rod between the rigid supports like this, and then I am heating. I am heating nothing but this rod is trying to expand. Whenever it is trying to expand, at that time I am not letting it to expand. Why? Because I supported with the fixed supports. So that what happens nothing but in that stress will get developed. Due to that stress Stress will get developed nothing but it is getting trying to get expanded. So this will apply force on my hand, but I don't want it to expand, so that only I am applying the same force in the opposite direction. In the same way, from both the sides force will act. Now for that, first of all you have to find out that force, how much force applied by the wall. So for that, y is equals to what is the formula, FL by AE, then F is equals to YA into delta L by L we got. Now I don't know this delta L by L value. For that purpose you have to apply the thermal expansion concept. In thermal expansion, L is equals to L naught into 1 plus alpha delta T we got. Then delta L by L is how much you will get, alpha into delta T, that you substitute here, and then you will get exactly F is equals to YA alpha delta T. This is the force applied by the wall, otherwise by the rod. Anything is, both are same only, equilibrium. Then this is the force I got, I want to get the stress, thermal stress means F by A. I got the stress, I want to get the energy, nothing but what is the energy formula, half into stress square divided by Y into volume. Otherwise you can take even half into stress and then strain into volume also. Then also you will get the same answer, there is no change in that. This is the thermal energy. Clear? Copy that. Here is Gautam. Absent yake? First time, first dose avade. First dose. ಮತ್ತೆ ಯಾರು ಆಬ್ಸೆಂಟ್ ಆಗಿದ್ರು? ಸೈಫ್ ಬಂದಿಲ್ಲ ಏನು? ತಾವೂಸು ಇಬ್ಬರದು ಒಂದೇ ಊರಾ? ಇವರು ವಸಿಷ್ಠ ಬಂದಿಲ್ಲ. ಟಿ ಜಿ ಎಲ್ಲಿ ಹೋಗಿದ್ರೆ? ಇಲ್ಲಿದ್ದೀರಾ? ಏನು ಟಿ ಜಿ ಏನೋ ರೋಗ ಬಂದಿದೆ ಅಂದರು, ಸ್ಲೀಪಿಂಗ್ ರೋಗನಾ, ನಿದ್ದೆ ರೋಗ? Harsha, how many marks you got? Harsha R 500 and something, right? How much marks? Very good improvement. Dhanush 480. Then you 540. 14. Good. Kalesh 370. Girls Kirtana 366. ಬರೆದಿಲ್ಲ ಎಕ್ಸಾಮ್. ಮತ್ತು ಯಾರಿದ್ದಾರೆ ಸೆಕೆಂಡ್ ಇಯರ್ಸ್ ಅಷ್ಟೇನಾ? somebody said that 180. ವಿನತಾ ಏನಾಯಿತು ನಿಮ್ಮ ಮಾರ್ಕ್ಸ್? 180 ಅಂದಿಲ್ಲ ನೀವು. ಮಾರ್ಕ್ಸ್ ಬಂದಿಲ್ಲಲ್ಲ. she got 180 out of 180. very good. then next marks 175 somebody, Namrata. Then 170 above anybody? 170 like that. What Ramesh, how many you got? 150? 150 ಅಷ್ಟೇ. Then 160 above ಯಾರಣ್ಣ? how many marks ma Rajeshwari? 162. good. Then how many marks you got? 151. 155. ನೀವು ಯುವರಾಜ ಬರ್ದಿಲ್ಲ, ನೀವು ಬರ್ದಿಲ್ಲಲ್ಲ? 140. 140. Anybody else 150 above? ಯಾರು? ಏನು ಶ್ರೇಯಸ್ ನಿಮಗೆ ಜಾಸ್ತಿ ಬಂದಿದೆ ಮಾರ್ಕ್ಸು? ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ. ಯಾರು? ವರುಣ 180 out of 180ನಾ? ಯಾವಾಗ ನಿದ್ದೆದಲ್ಲ? ನಿಜನೇನಾ? ರಿಯಲಿ? ನಿಮ್ಮದು 180 ಬಂದಿದೆ ಅಂದರೆ ಅವ್ರದ್ದು ಯಾಕೆ 175 ಟಾಪ್ ಆಗ್ತಾರೆ? ನೀವು ಆನ್ಲೈನಲ್ಲಿ ಯಾಕೆ ಬರ್ದೀವಿ? ಊರಲ್ಲಿ ಬರ್ದೀವ ನೀವು? ವಿತ್ ಬುಕ್ಸಾ ವಿತೌಟ್ ಬುಕ್ಸಾ? ವಿತ್ ಫೋನ್ ವಿತ್ ಗೂಗಲ್ ವಿತ್ ವೇದಾಂತು ಆ್ಯಂಡ್ ದೆನ್ ವಿತ್ ಟಾಪರ್ಸ್. ಆಸ್ಕ್ ಮಿ ಡೌಟ್ ನಟ್. Write a problem. A steel wire of length 20 centimeters. ಏನು ಹರ್ಷ ನಿಮಗೆ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಆಗ್ತಾ ಇದೆ? ಅಲ್ಲಿ ಹೋಗ್ತೀನಿ. A steel wire of length 20 centimeters and uniform cross section 1 millimeter square. Steel wire of length 20 centimeters. Length 20 centimeters and uniform cross section 1 millimeter square. 1 millimeter square is tied rigidly at both ends, is tied rigidly at both the ends if the temperature of the wire is altered from 40 degrees Celsius to 20 degrees Celsius. Calculate the change in tension. Calculate the change in tension. In bracket, coefficient of linear expansion of steel is 1.1 into 10 power minus 5. 1.1 into 10 power minus 5 per degree Celsius, and Young's modulus for steel is 2 into 10 power 11 Newton per meter square. Calculate the tension, you have to find out. Okay, amount huh? 40 to 20. You have to find out the tension. What is the answer? 44 newtons is the correct answer. 44 newtons is the correct answer. Force is nothing but tension only. Force is equals to tension. You have to take Ya alpha delta T. There is no other formula. Young's modulus given. Area given, huh? 1 millimeter square I have given. Everything given. Can you find out the energy stored? Thermal energy. Find out the thermal energy then. Force is 44 newtons. How many of you got that? Raise your hands. Very less. Good. Very less. Why remaining people? Y alpha delta T only. Ya alpha delta T. Find the thermal energy also. Yes, who got 180? Vinuta? Take it. Very good. Keep it up. 5 rupees chocolate ani anukobedri. Very good, Nana. Very good. Then one more next. Namrata, come. Yarige share ಮಾಡಬೇಡ್ರಿ. ನೀವೇ ತಿನ್ನಬೇಕು. ಯಾರನ್ನ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಮೇಡಮ್ ಕೇಳ್ರಿ ಅನ್ನಂದು. Very good, ma Namrata. Then anybody? Next top marks who? Varun kodalla. Next 160 above yaro andru. Estama? 162, come. Very good, Nana Rajeshwari. Keep it up. Then next. 96 point? Correct? 96.8 you got. Then next chocolate yaru 150 above yaru bandide? Ramesh. 150? 150 exactly. Neevu? 155. Next girls? 150 above yarilla. Take Pramod. Give to Ramesh also. Share it. Don't give to Yaraja. Moreover for Shreyas also. ನಮಗೆ ಯಾಕೆ ನಮ್ಮ ಥರನೇ ಜಾಸ್ತಿ ಇದ್ದಾವೆ. ಭಾಳ ಜನ ಗರ್ಲ್ಸ್ ಕೊಡ್ತಾರೆ ನಮಗೆ, ಇವ್ರು ಯಾಕೆ ಕೊಡ್ಬೇಕನೆ. ಎಸ್ ಯು ಗಾಟ್ ದಟ್. F is equal, you will get tension is equals to 44 newtons here. What is the Young's modulus I said? 2 into 10 power 11. Area is how much? 1 millimeter square, right? 1 into 10 power minus 6. 10 power millimeter square they said, 10 power minus 6. Then alpha is how much? 1.1 into 10 power minus 5, then delta T is 40 to 20, nothing but 20. 40 to 20, right? That's it. So whenever you calculate, then tension is equals to how much you will get? 44 newtons. That is the tension you got. Then energy, thermal energy, you have to calculate nothing but half into y alpha into alpha square into delta theta square into the volume. Volume nothing but what? Area into length. Why? Because length is given there. How much length is given? 20 centimeters. Substitute and then you will get the answer. What is the answer you got? 186. 96. Approximately 96 is the answer. 196. ಏನಮ್ಮ ಎಷ್ಟು ಆನ್ಸರ್ಸ್ ಹೇಳ್ತೀನಿ ನೀವು? 196 is the answer. Yes, approximately 196. ಅದು ಬುಕ್ಕಲ್ಲಿ ಇಲ್ಲ. Next. Torsional rigidity finished. Next, write a problem. A thermal stress, no, strain of a uniform rod is delta L by L. Strain of a uniform rod is delta L by L. Then its Poisson's ratio is sigma. Then find volumetric strain. Already we have done this kind of numerical, but I will tell you the shortcut formula for this by this problem. Now I said that strain is how much? Delta L by L of a uniform cylindrical rod you have to take, and then you have to find out what, by the way? Delta V by V. They have given the Poisson's ratio sigma, and then you have to find out the delta V by V. For the delta V by V, what you have to do? Nothing but first of all you have to take the volume of the cylindrical wire. What is the volume of the cylindrical wire? Pi r square into L. See that there are only few formulas are useful in these solids. First one is about the cube. Whenever they have given the cube of side L, means area is how much? L square. Volume is how much? L cube. Whenever they have given the cylindrical wire, at that time it will have two areas. One is the curved surface area. That formula is 2 pi RL. That is not yet come, whatever the problems we have done, but the area you remember 2 pi RL. That will come next in the punching of hole, it will come. Next one is bottom surface is the circular surface. So what is the area of that? Pi r square. So that is about the areas of cylinders, and volume of the cylinder is how much? Nothing but that is pi r square into H you will get. So here volume is equals to, we will get it as what? Pi r square into length of the cylinder is L here. Now you have to find out the delta V by V, means delta V by V is equals to what I can write here? 2 into delta R by R plus delta L by L. Errors method again you have to apply. So that, what about the pi value? Constant, it will not change anything, so that 2 into delta R by R plus delta L by L. That is about the delta V by V, change in the volume. Now you want to get, they have not given any radius here. For that purpose, what you have to get? Nothing but you have to get this formula in the terms of sigma. Why? Because sigma they have given Poisson's ratio. For that, what we can do, let us check. Sigma is equals to, what is the formula for us? Minus delta D by D divided by delta R by R. You have exam on the day after tomorrow and you don't know the formulas, means what you will write in the exam? Poisson's ratio sigma is what? Lateral strain by longitudinal strain. So minus delta D by D divided by delta R by R. That is the formula. Then instead of delta D, what I can write? Delta D by D. I can even write it as, what is it? Delta L by L, right? Delta L by L. Instead of delta D by D, what I can write? Delta R by R divided by delta L by L. Now in the place of delta R by R, what I can write? Minus sigma into delta L by L. Is that correct? In the place of delta R by R, I can write it as minus sigma into delta L by L. Now delta V by V is equals to, in the place of delta R by R, what I can write? Minus sigma into delta L by L plus again what is there here? Delta L by L is there. Now what I can take out here? Delta L by L I can take out. Then what is remaining here? 1 minus 2 sigma. This is the shortcut formula to find out the change in the volume, percentage change in the volume whenever they have given the strain. linear strain they have given. At that time this is the formula to find out the change in volume. On that day also I said one formula based on this, one problem based on this. You remember that? Tell me what are the values I have given? In Poisson's ratio problems, one problem I have given to find out the percentage change in volume. Sigma is equals to how much? 0.2. Then length, linear strain they have given directly. Longitudinal strain. How much they have given? Delta L by L. 3 into 10 power minus 3. These are the values they have given, and then they have asked the volumetric strain, percentage change in the volume. For that, what is the formula we can use? Nothing but delta V by V is equals to delta L by L. How much that is? 3 into 10 power minus 3. 1 minus 2 sigma nothing but 2 into 0.2, that is 0.4. So 3 into 10 power minus 3. This one will be how much? 0.6. So only on that day we got it as 1.8 into 10 power minus 3. You remember this one? Yes sir. So directly whenever we substitute in this formula we can get. On that day we have done everything, this one and all we have done. So this is a shortcut method for that. Now V is equals to pi r square into L. From that here whenever you differentiate that one, whenever you apply the errors method, at that time delta V by V is equals to 2 into delta R by R plus delta L by L. In the problem they will not give the radius, they will give only longitudinal strain only. So for that purpose, for the delta R by R, we can take it as sigma is equals to how much? Minus delta D by D divided by delta L by L will get. Instead of delta D by D, what I can write? Delta R by R I can write. So that delta R by R is equals to how much? Minus sigma into delta L by L. That value exactly I substituted here. And then delta V by V is equals to how much you got? Delta L by L into 1 minus 2 sigma. Clear? On that problem we can substitute in that directly and then we can get the answer. Clear? Copy that. ఇప్పుడు అర్థమైంది ఎలా వచ్చింది ఆ ఫార్ములా సార్? ఆ రోజు బై హార్ట్ చేసుకొని వచ్చావు కదా. Have you solved the assignments? First one you finished at least. Second one also you got right. You want means I will give one more. That is not yet finished or finished. Finished means I will give one more. Finished. Not finished. You have to finish it. Next. Series and then parallel combinations of metallic wires. Series and parallel combinations of metallic wires. Series and parallel combination of metallic wires. In this mainly you have to find out the effective Young's modulus. They have joined two rods of Young's modulus y1 and then y2. You have to find out the effective Young's modulus. For that purpose, first of all I will take the series combination. In that series combination I have two rods. This one is of Young's modulus y1 and then length is L1. Another wire I am having and then I am joining in the series. Series I have to join exactly without any difference means same area should be there or different area should be there. Same area should be there. One after another, two pipes you have taken for example. Two pipes you have to join exactly without any difference. The water should not leak nothing but you have to take the same area pipes only. Same area pipes nothing but in pipe fitting it will be different. They will get a little bit bending will be there, and moreover the pipe will be of same size only. At the edge only you will get a little bit less area and the remaining pipe will be same size only. So in the same way here also you have to take the area of cross section is same and the length another is L2 and then Young's modulus is Y2. Now for that I am just hanging one mass here of M. Now tell me same force or different forces? Same force, right? Obviously force is same. Why? Because I have applied only one mass here. Clear? And now here I said that area will be same. Young's modulus is obviously different. You have to find out that effective Young's modulus only, and the length also different here. Whenever I draw the equivalent diagram for this, At that time what will get? Nothing but instead of 2 rods, how many you will get? After that only 1 rod of length how much? L1 plus L2, and then Y effective, Y series I have to find out, and by the way mass is M is hanging here. Is there any other things are there? L1, L2, I have taken total rod as L1 plus L2. Y1, Y2, total Y as a what? Y effective I have taken, otherwise Y series you can take, anything is same only. Now area should be same, then only I get the uniform rod, otherwise you will get the non-uniform rod there. Final rod should be uniform. Uniform nothing but both should have the same areas only. So this is the Y series. For that purpose, first of all, can I say that elongations are different? When elongations will be different? Because here Y is different and then rods are different here. So that what I can say, elongation is different. Total elongation is equals to what I can write? E1 plus E2. Elongation in the first rod plus elongation in the second rod is equals to total elongation of the total rod. So that E is equals to E1 plus E2. E is equals to, what is the formula from the Young's modulus? Y is equals to FL by AE. Then E is equals to FL divided by Y into A. So that FL divided by FL nothing but L is total what? L effective. This is the total effective elongation. Effective elongation is equals to E1 plus E2 you have to take. So that F into L effective, that divided by area. Area same or different? Same area, there is no change in the area, and then Y effective you will get. That is equals to E1. Elongation in the first rod. What is the elongation in the first rod? E1 is equals to what I can write? F1 L1 A1 by Y1. You will see that. F1 L1 A1 by Y1. Can I say F1 then A is same? F1 then A is same. So that FL1 by AY1. Then second one, for the second elongation what will get? F2 L2 by A2 into Y2. Again force is same, area is same. So that only again F by A I have taken. Now what will get cancelled both the sides? F by A gets cancelled. Then L effective, how much effective length is there here? L1 plus L2. So that L1 plus L2 divided by Y series is equals to L1 by Y1 plus L2 by Y2. Obviously the materials will be different, not same. One may be steel, another might be copper, otherwise aluminum, copper, like that. Already we have solved that kind of problem. Aluminum, copper in series combination we have taken. Did you remember that? Yes, that kind of problems will be there. Series combination only, but different materials will be there. So Young's modulus will be different. If in this case, one more advanced case we will take in this. If in this case, if the lengths are same, I have taken the lengths are same, L1 is equals to L2. Then what is the formula? You will get Y effective is equals to L1 plus L2 is equals to how much? 2L. 2L by Y series is equals to L by Y1 plus L by Y2. LL gets cancelled. Y series is equals to what I can say? 2Y1 Y2 by Y1 plus Y2. This is a series combination of 2 rods. So Y series equals to 2Y1 plus Y1 into Y2 by Y1 plus Y2. Here in this mainly you have to remember is which one is same, which one will be different. You want to combine in series combination nothing but compulsory area should be same. In parallel there is not necessary that area might be different also. So in series area should be same, and also materials of different materials. And now you have to take the same force only. Why? Because by applying only one force I am having the elongations in this. First one is elongating as how much? E1. Second one elongation is how much? E2. Total elongation will be how much? E is equals to E1 plus E2. I have taken just Young's modulus formula, that's it. So in series combination you write on the top of that area should be same, and then what should be same again? Force. Force also same, and then L is different. L is different and then Y is different. Elongation is different mainly. That is about the series combination. Tell me what should be same in the parallel combination? Whenever you are adding 2 in parallel, whenever you are taking 2 parallel rods, at that time I want to add them as a 1. So that what should be same? Length should be same. Can I say elongation also same? Why? Because at the end of the day, after the combination, they should be in the same length only again. So that what I can say, elongation is same and then length should be same. Areas might be different. Areas might be different. There is no need of that we have to take the same area only. Areas might be different. Then again, force will be different. Why? Because whichever is having more area, that will bear more force or less force? More force. Whenever it is having, for example, I have taken 3 rods together like this and then I am hanging 10 kg mass. Then what happening? Nothing but it can bear easily. Whenever I take only one and then I am just leaving 10 kg mass here, it cannot bear. What is the reason? Nothing but here areas are different, so that the force, what is the stress formula for us? Stress is equals to force by area. If area is different, nothing but force also should be different only, right? You understand now at least? So force is different and then area is also different. Then stress will be different in that. See that stress is equals to force by area, so that if I take the area is different means, for example, I am there, I am thin, so that I can bear only few, some sort of stress only I can bear. If you take the other person who is already very strong and then he can bear more stress. That is directly depends on the area of the rod only. So whatever the rod we have taken, for the rod area only it will depends the stress, how much stress it will bear. So stress area different, nothing but obviously the force also will be different only. If the force is same, then stress will be same. Understand or not? So that you just remember that whichever is having more area, that can bear more stress. Whichever is having less area, that can bear only less stress. So here I can say that force is different, F is different. F is different. You are only saying that length is same. Whenever you want to add them parallelly, nothing but, for example, one is longer I have taken, one is shorter I have taken. Can I add them parallelly? If I add them also, they cannot become uniform. I want to make it a uniform only. So that what should be there, nothing but length should be same. I want to make a uniform total rod, nothing but at that time elongation also should be same. For example, it is elongating more, this one is elongating less, nothing but I will get like this. Non-uniform rod I will get at the end of the day. So that elongation should be same. E1 should be is equals to E2 and then L1 should be is equals to L2. Then F is different. Obviously the Young's modulus also different only. That is only you have to find out. Young's modulus only finally. So that here Young's modulus is Y1 and then Y2. Here Young's modulus is Y parallel, effective Y. Clear? Can you find out that? Y parallel? Right, as a problem. Two different rods of same length undergoes same elongation of areas A1 and A2 their Young's moduli Y1 and Y2 added parallelly with each other, then find the effective Young's modulus. Find the effective Young's modulus of the combined rod. Effective Young's modulus of the combined rod. What's the answer? Yp is equals to, we have to find out. I said here y is different, nothing but you have to find out the y only. I said force also different. So net force is equals to what I can write? F is equals to F1 plus F2. Now you substitute and then get the answer. This much time. Yp is equals to what is the formula? Y1 A1 plus Y2 A2 by A1 plus A2. If the areas are same, Y1 plus Y2 by 2 you will get. That's the correct answers. So here F is equals to F1 plus F2 means F is equals to what is the formula for us? Y is equals to FL by AE, and then F is equals to YAE by L. Correct? So that YAE by L. Y parallel, A parallel into E and then L are same only I said. That is equals to Y1 A1 E by L plus Y2 A2 E by L. This is what you will get. I said E is same, L is same, then only parallel combination is possible for the uniform. Non-uniform means however you can add. This is not about the resistors, not about the capacitors. Uniform rod only you have to get at the end of the day. For that I have to take the same lengths and then same elongations. So here F is equals to F1 plus F2 means Y parallel, A parallel, E parallel by L parallel is equals to Y1 A1 E1 by L1, Y2 A2 E2 by L2. How we got that? Nothing but the Young's modulus formula. Y is equals to what is the formula? FL by AE, then F is equals to YAE by L. Then here E by L gets cancelled everywhere, and then Y parallel, A parallel area is how much totally? One is A1, another is of A2. So that what will get totally? A1 plus A2 is equals to Y1 A1 plus Y2 A2. Then Y parallel is equals to what is the answer you will get? Y1 A1 plus Y2 A2 divided by A1 plus A2. If I say A1 is equals to A2, areas are same. So that if A1 is equals to A2, then Y parallel is equals to what is the answer you will get? Y1 plus Y2 by 2 you will get. So that Y parallel is equals to Y1 plus Y2 by 2. That's it. That's the final answer for the parallel combination. Series combination is nothing but what? 2 Y1 Y2 by Y1 plus Y2, like resistors only. What is the resistors series combination? Nothing but R1 plus R2, like capacitors by the way. Capacitor series combination is what? C1 C2 by C1 plus C2, but here you will get 2. Why? Because we are taking the same lengths here. Here parallel combination of capacitors is how much? C1 plus C2. If we take the same areas, at that time it will be Y1 plus Y2 by 2 we will get. Clear? That is about the combinations. Next problem. Next. Find force required. Find force required to punch a hole of radius r and length L, radius r and length L from a cube, from a metallic cube. So here I am taking a metallic cube. In that metallic cube I want to punch a hole. Completely I want to take a cylinder, obviously. Whenever you are taking, you are punching the hole for the cube, nothing but for example any plate I have taken, otherwise I will take any book. For the book you are punching hole means what you will take out? Cylinder only, right? You will take out. So that force you have to find out. Stress is equals to what is the formula for us? Force by area. And then force by area nothing but I am taking which area? Nothing but cylindrical area. So that here first of all you have to find the stress. Stress is equals to force by area here. This force required you have to find out. For that whenever I punch a hole like this, then how I am getting? Nothing but I am getting like this. Correct? This is what I will get out. Whenever I punch a hole for this, for a cube, I will take a cylinder out. So that's this cylinder of radius, how much they are saying? R is the radius and length is how much? L, or thickness of the cylinder is L I can say. Now whenever I take it out, I am taking entire cylinder is out, nothing but which area you have to consider? You are taking only circle out, otherwise circular plate you are taking, a circular cylinder you are taking. Cylinder nothing but what you have to take, curved surface area. Correct? This surface area of the cylinder you have to find out. Why? Because I am taking this entire thing out. I am not taking only upper surface. If I take only upper surface, I will take pi r square only. But this work also I am doing here. I am not only taking the upper layer, I am taking entire cylinder nothing but I am doing this much of length work also. So that the force required F is equals to what I can say nothing but that is a stress required, stress applied into area of the curved surface of the cylinder. So stress into area of the curved surface, how much? Just before I said 2 pi RL. 2 pi RL is the curved surface area. Whenever you see the circular surface area, how much? Pi r square. For the cylinder you will have two areas. One is curved surface, another is this one, circular surface. So that what is the formula? You will get nothing but 2 pi r into L. Might be getting confused about why I have not taken pi r square also. Pi r square is there within this only. Understand or not? So why? Because whenever you take the number of discs, then what you are forming there? Cylinder. Whenever you keep one disc on the other, one disc on the other, one disc on the other, what you are forming there? Cylinder you are forming. For example, if I find out total area, then I am finding the area of the disc also, right? Total area of the total cylinder if I find, I am finding the disc area also. So that here, stress into the curved surface area you have to take. Why? Because you are taking entire cylinder out, not the plate. For example, if they said that whenever you are taking a plate without any thickness, very negligible thickness is there, and then you are punching a hole for that. Now tell me what is the force required? Only this one, circular plate you are taking out. What will get? Stress into pi r square, that's it. Area is pi r square only. Why? Because I did not say that thickness is there. Thickness is not there, so only pi r square. If thickness is there, nothing but pi r square into T we will get. Okay. Now, whenever it is not correct. Why? Because whenever thickness is there, that will become a cylinder. For the cylinder, what is the surface area? Nothing but that is a 2 pi RL. 2 pi R plus L. No, circular one already it is coming out of this only. It is already included. Circular one is included. This is the correct answer. 2 pi R into thickness we will get. So this is the force required. Copy that. Punching of hole. What's your doubt? Tell me, Pramod. Pi r square plus 2 pi RL. Pi r square plus 2 pi RL. Correct. But this pi r square you already cylinder already. Total area means you have to find out. So what is that? Stress already. Stress in the stress what you are having, force by area is there already. Not even stress only. Inside of the cylinder only you are taking this discs already out only. The circular surface is also you are taking inside of the cylinder only. There is no need to consider again that one. If I say total area nothing but at that time you have to take it as pi r square plus 2 pi RL. In mathematics we will do that only, right? Total area of the cylinder is pi r square plus 2 pi RL we will take. But here we are doing the work on only curved surface only. Whenever I punch a hole, you are travelling only this much of distance. So that what we can take nothing but only curved surface area you have to consider. 2 pi RL. Clear Uday? Then series parallel combination finished, right? Yes, now write a problem. Find the initial length of the wire. Find the initial length of the wire. Find the initial length of the wire if the length of the wire is L1 when applied tension is T1. Length of the wire is L1, then tension is T1. Length of the wire is L2 and the tension is T2. Tension is T2. See that you have to find out the initial length. Initial length you have to find, and the length at tension T1 is how much they have given? L1. Length at tension T2 is how much? L2 given. You have to find out the initial length, means what we can do? What we can do? L1 tension is, L1 length is there whenever I apply the tension T1. L2 tension is, L2 length is there when I apply the tension is T2. Original length is considered as L. Yes, you have to take the extension. Elongation is directly proportional to the applied force. Yesterday itself we said no, elongation is directly proportional to the applied force. So applied force is what here? Tension only. If I take E1, then tension is how much? T1. If I apply more tension, at that time there will be more elongation. And again one more is E2 is directly proportional to what I can say? T2. If I apply more tension in the second case, then elongation is how much? E2 here. Now you have to get the elongation in terms of L. Let me take the initial length is L. From length L, by getting the E1 elongation, we are getting final value is how much? L1. Initially length L is there. Initially length L is there of the rod. On that, whenever I apply force, then what will be applied automatically? Tension will be applied. By that tension, what happening? Nothing but it is elongating. After elongation, how much length it is becoming as nothing but L1 length. Now, for the same rod again, same rod I have taken. Again I applied different force, so that I will get the different tension. If different tension is there, nothing but elongation also different only. So with that initial length L plus E2 is equals to length second time how much they are saying? L2. After including the elongation only, initially length L was there. For example, initially a 10 centimeter wire I have taken, and that I have applied 10 newtons force. Whenever I apply 10 newtons force, it is elongating for 1 centimeter. Total length is how much here? 11. That is what 11 they have given here, L1. Now, instead of applying 10 newtons, I applied 20 newtons force. Then elongation is 2. Then total length is how much now? Same 10 centimeter wire only. Elongation is becoming as how much? 2 means total length will become how much? 12. That 12 only they are giving here. After applying the tension, final length they are giving. So that, can I say that L plus E is equals to L1? Initial length L plus E1 is equals to L1. Initial length plus elongation, first elongation is equals to total final length of the first rod in first case. Second case is L plus E2 is equals to what I can write? L2. Initial length plus second time elongation is equals to total length how much? L2. Whenever they applied how much tension here? T2 tension. Here how much tension is applied? T1 is the tension applied. Clear? Any doubt in that? Initial length is L. 10 centimeter was there. Initially 10 centimeter was there. Now applied 10 newtons force. So that 1 centimeter extended. 1 centimeter elongated. Total length is how much finally? 11. Why? Because here 10 centimeter plus 1 centimeter elongation gives you 11. Whenever I applied how much force here? 10 newtons force. 10 newtons force means obviously 10 newton tension only. Then second case, same wire I have taken again 10 centimeters length only, but now elongation is 2 centimeters because I applied how much force? Nothing but 20 newtons force. Then total length will become how much here? 12 centimeters it will become. So 12 centimeters is there whenever I applied 20 newtons force. 11 centimeter is there whenever I applied the 10 newtons force. The same thing here also they are giving. So now L plus E1 is equals to L1 means, then can I write it as E1 is equals to L1 minus L, and then E2 is equals to how much? L2 minus L. Understand it clearly? Then L1 minus L is equals to T1, directly proportional to T1 obviously, and then this is L2 minus L is directly proportional to T2. I want to get the L value from this. Then what I can do? In terms of T1, T2 only, I want to get the L value. What I can do? I can divide them. And then cross multiply easily. So that I want to get the L only. Whenever you do the addition or different subtraction, at that time L gets cancelled here. L will not be there. But you have to find out which one? L only, initial length only. So for that I will just divide them. then L1 minus L is equals to T1, that divided by L2 minus L is equals to T2. Whenever I do the cross multiplication, then what will get here? T2L1 minus T2L is equals to T1L2 minus T1L. Which you have to find out? L you have to find out, so that get T1L this side, then I will take L common directly. T1 minus T2 is equals to T1L2 minus T2L1. Everything correct? Check that. So then L is equals to, total length initially is equals to T1L2 minus T2L1 by T1 minus T2. Clear? That is a formula to find the initial length. Some of the people got this doubt to me, I think girls. So this is L is equals to T1L2 minus T2L1 by T1 minus T2. Let us check this one. We will get the 10 centimeters or not, we will check. Okay. Initially how much I said? Length is how much? L1 is equals to how much we got? 11 we got. Initial length is 10 we have to take. That one we will get or not, we will check. Tension, how much tension I applied? 10 newtons. I got the 12 centimeters whenever I applied how much force? 20 newtons force here. Let us check that. So here T1 is how much? 10. L2 is how much? 12. Minus T2 is how much? 20 newtons. And then length is how much here? 11. And then T1 minus T2 nothing but how much you will get here? 10 is the answer. Then 120 minus 220 na? 220 divided by 10. How much is the answer? Minus 10 na? Yes, T1 minus T2, yes, minus 10. This will be how much? 100, right? 100 by minus 100 by minus 10. What is the answer? 10. Our answer is correct only. What we considered initially 10 centimeters only, we got that only finally also. So this is how you have to do. Elongation is directly proportional to the applied force. By solving the F is equals to Kx, we got this one. K is equals to, what is the formula? Do you remember that? YA by L. Yesterday, force constant formula. For solving that one, I said that force is directly proportional to the elongation. Here also the same thing only. Instead of force, what you will take? Tension. Tension is directly proportional to the elongation in the first case, and then tension is directly proportional to the elongation in second case. Now elongation in the first case is initial length plus elongation is equals to final length. Initial length plus second elongation is equals to second final length. That is what I have done. Initial length plus first elongation is equals to first final length. Initial length plus second elongation is equals to second final length. From that you have to find out the E1, E2 values. That values you substitute here and then divide the equation. Then you will get the L value here. Clear? Copy that. Did I say about the elongation in the problem? Did they give the elongations? Copy the problem first, I will tell that. Hello sir. In that question only just continue. Question only continue. Elongation is E1. Elongation is E1. Elongation is E1 by T1 and E2 by T2. Elongation is E1 by T1, E2 by T2. Next one is malleability. Two theory concepts are there, we will finish it. Malleability. So what is the malleability? Nothing but everything we discussed, everything about the expansion only till now. Now we will discuss about the compression. in compression. For the elongation, if you see in the stress strain curve, we have discussed up to point A, what happens? Stress is directly proportional to strain, so only we call it as what? Proportionality limit. From A to B, elastic limit, stress is not directly proportional to strain. And then B to C, yield point, from there it will loses the elastic nature and then wire starts yielding. C to D, for the smaller stress also there will be larger strain will be there, and also we call it as ultimate tensile strength. Next D to E, what happens? Whenever we are decreasing the stress also, there will be increase in strain, after that wire will get breaked. That is what we discussed about the elongation of the wire under a gradually increasing load. Whenever you see the compression, for example, I have taken a wire, otherwise rod, on that I am applying a force. Whenever I apply a strong force, at that time what happens? It will get compressed. Whenever it will get compressed, up to some limit it will get compressed. After that still I am applying the force. Then what happens? It will get crushed. There breaking point will be there, here crushing point will be there. It will get crushed, right? Whenever you are taken any steel rod, for example, for the steel rod you are applying force from the bottom end. So whenever you are applying force, up to some extent it will get compressed. After that what happens? Nothing but it will get crushed, otherwise it will bended. So that point is known as the crushing point. Instead of breaking point, we will get a crushing point here. So malleability nothing but the limit how much it can compress it, and after before crushing how much it can get compressed. That ability is known as a malleability. If the wire is having more malleability, at that time what happens? Nothing but it will crush lately. Slowly it will get crushed. More malleability is there, nothing but compression is easy. Compression is easy, so finally it will get crushed. Whenever any material is having less malleability, at that time what happens? Nothing but it will get crushed very fast. For example, if I take the plastic rod, otherwise glass rod. If I compress the glass rod, then what happens? Compression will not be there, directly crushing only, correct? Why? Because it is having the less malleability. Whenever you take the steel rod, at that time it will have the more malleability. Clear, right? That is about the malleability. Malleability is nothing but the ability of the material which can stay without crushing. So it is having more malleability, nothing but we can compress more. For example, you can take the spring, we can compress more, it will not get crushed. Whenever you take the glass rod, it will get crushed easily. Why? Because it will have less malleability. Clear? That is about the malleability. Next one is elastomers. Elastomers. What do you mean by elastomers? Nothing but, first of all, I will tell the example only directly. Rubber is the elastomer, best elastomer. What is the reason? Nothing but I can stretch more, I can produce more strain without breaking. Why? Because whenever you see the rubber, we can produce more strain. Strain nothing but what? Change in the length only. I can produce more elongation without breaking it. Instead of rubber, if I take the normal thread, normal white thread if you take, whenever you are applying the same force on that, then what happens? It will get breaked. It is getting breaked easily. Why? Because it is not elastomer. Whichever is the elastomer, that will not get breaked easily. It will have more strain. So that property is known, that whatever the objects which are following, that property is known as the elastomer. And also I don't know what is that name, aorta something in a human heart. AORTA na? Why R? R is not happening. R is silent. Iota na. So what happens? Nothing but that is also elastomer only. Why? Because it will stretches more if there is a more blood pressure. So that is also best elastomer in the human body, within the human body only. I don't know the pronunciation. I even listened for the first time that one. In the last year also the same thing happened. Iota, correct? Yes, I will remember that. So that is also elastomer. Elastomer nothing but what? We can stretch up to the more length without breaking. Malleability nothing but what? We can compress for the more value without crushing. Crushing is happening nothing but happening fast, nothing but that is having less malleability. For example, whenever you are stretching, at that time it is breaking nothing but it is not elastomer. Elastomer nothing but it will stretches for the more value without breaking. Clear, right? Write the two definitions, malleability and then elastomer. Malleability. occurs in the compression, occurs in the case of compression, occurs in case of compression. The property of the material, property of material which can bear maximum compression without crushing, which can bear maximum compression without crushing. Which can bear maximum compression without crushing. The materials with more malleability, the materials with more malleability can be bent, rolled and hammered easily, can be bent, hammered and then rolled easily. You understand that what I said the example? In example what happens, nothing but whichever is having more malleability I can fold it. If I fold a glass plate, then what happens? It will get breaked, it will get crushed. If I fold a iron plate, then what happens? It can bend. So whichever is having more malleability I can bend it, even I can roll it, even I can what I said, hammer it. Those are the properties whichever we can do with a more malleability. Clear? Next one is elastomers. 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 The materials which can be stretched for the longer strain, which can be stretched for the longer strain without breaking, without breaking. Examples, right? Rubber and then iota, iota. Video.